So this is a continuation to the previous video where I showed you guys that the volume of a cone is 1/3 of the volume of a cylinder with the same base and the same height. And the idea is, suppose you start with a line like this and rotate it about the y-axis. You are going to get a cone like this. And in fact, this cone is just going to be 1/3 of the volume of its surrounding cylinder, which will look something like this. Now, I've always been wondering the following. Suppose this is a bucket of ice cream. If you just take this amount out, you are only eating 1/3 of the bucket of the ice cream, which is not so fun. I want at least half of it. So the question is, how are we going to do it so that we can actually take out half of the amount of the ice cream? And let me formulate the question like this. For what curve do we need? Let's say just this portion here, so that if I do a rotation about the y-axis, which will end up something like this, this right here will be half of the volume of the surrounding cylinder. Pretty interesting, right? And then let's just focus on getting y equals x to the k's power in this form. And feel free to try with another equation and all that. And if we can solve it, then next time you know how are you going to screw up the ice cream from the bucket of the ice cream. So you can take out half of the amount, which is pretty cool. Okay, how do we do it? Well, firstly, we still have to use the disk method. So if you make a horizontal cut like so, let's analyze this real quick. The radius will be the x. Because remember, in the middle, here we have the y-axis. Right, the horizontal distance is the x. And then the thickness is the y. And now, in fact, there's a shorter way to do it. The idea is that if you have this shape, all the such shapes will be similar. You can make it like bigger, scale it up, or scale it down. So we consider the easiest case. Let's say we just want to go from 0 to 1. And it will work with 1 and others. It's much simpler. Because if you say from here to here is 1, that means from here to here is 1 to the k's power. So it doesn't matter what k is, you will get 1 as well. Much better. Now, the blue disk has the volume pi r squared h. Pi is pi, the radius r is the x here, so it's x squared, and the height is the thickness here, which is dy. This right here is just one disk though. We have to add up all the disks from the bottom to the top, and we will integrate it from 0 to 1. And this is the volume that we want. And of course, we want to set this to equal what? Half of what? Of the surrounding cylinder, which we can just use the formula pi r squared, and r is 1, and the height is 1. So it's just half pi. So we want this equal that, and then we can solve it. Actually, x squared is the answer. I'm sorry. Oh my god, no. No, k squared. Okay, I forgot. Anyways, this is radius squared, but okay, fine. The answer is k is equal to 2. Anyways. Alright, so now, if you look at this, I need to solve for x in terms of y. Let's look at this and raise both sides to the 1 over k's power. So it's y raised to the 1 over k. Put that here. So we are looking at the integral from 0 to 1. Put the pi to the outside, and then x is that 1 over k, y to the 1 over k, and then squared, and then dy, and that is equal to half pi. We can get rid of the pi from both sides, and then this right here is y to the 2 over k. So add 1 to it, you get y to the 2 over k plus 1, and divided by the new power, which is 1 over 2 over k plus 1. Yeah, and then we just have to go from 0 to 1, and we have to make it equal 1/2. It's much easier if you just consider the unit case, which is when the r is equal to 1. If not, if you consider this as r in general, you will end up with r to this power over that, and then equals 1/2 r to something. Slightly more complicated. It's still doable though, but just do it. Yeah, with a unit case when r is equal to 1. Anyway, when you're putting 1 into dy, 1 to this power doesn't matter. We just have this. So 1 over, get the common denominator, which is the k. So that is 2 plus k over 2. Plugging 0 is just 0, doesn't matter. And then we have 1 over 2. So that means this has to be equal to 2. And do all that, k is equal to 2. I thought I accidentally wrote down, but anyways. Yeah, so the idea is that next time you can scoop out the ice cream in the parabolic manner, then that will give you half of the amount of the cylinder that's around it. It seems pretty cool. That's it.